In my presentation, I'll focus on a couple of things. One is over the past two and a half years, we've developed a lot of insights into small cell deployments based upon our SP Wi-Fi and femto deployments. So I wanted to share some of that with you. And also share with you our strategy moving forward. Where are we investing? Where do we see some of the unique challenges? Where are we looking to partner with the industry at large? And walk you through some of our thoughts there. Now, in terms of technology itself, there are some massive transitions that have been going on over the past few years. I won't walk you through all of it. A couple of things are obvious. The way in which people use smartphones, the way in which people use tablets has completely reshaped the way in which networks are built, not just wireless networks, but enterprise networks and so forth. In addition to that, there are some of the trends that we are seeing which aren't quite as obvious yet because they're still playing out. And I'll point to a couple of things that you see on the end of the screen in the area of big data and analytics and the Internet of Things. And what we see happening there, let me just take the Internet of Things, is there's technology enablers. For example, the semiconductor industry has been able to build tiny chips, about this small, which cost 15, 20 cents, which integrate Wi-Fi, Bluetooth, processor, memory, and you're suddenly at the point where you can, and it's extremely low power, and you're suddenly at the point where you can embed that into just about every object that you can think of. And if you couple that with capabilities in the network in the cloud, all of a sudden, the possibilities are endless in terms of, the types of business services that you can enable using that infrastructure. So a lot of things going on, but in our world, in the mobility world, it essentially translates into two things. And at Cisco, we keep using the terms optimization and monetization. So optimization is referring to how do you run the network more efficiently? How do you do things to improve the user experience? How are you able to transport bits more efficiently, more cheaply? So, a lot of the problems that need to be solved fall into that realm. How do you make small cells is an obvious example, right, where we are trying to provide additional capacity, but do so in a cost-effective manner. So, a whole bunch of problems in that area. Likewise, as multi-standard radios make their way out into mobility networks with 3G, LTE, and Wi-Fi, it's obviously going to be important to make sure that users have a good experience in terms of being able to roam between these networks. So again, these are familiar problems. We've dealt with these before in other technologies, and we need to make sure that as we move forward with small cells, that we are able to solve them effectively. But the one area in which we believe that there is a shift, a significant shift in terms of how mobile networks need to be constructed is in the fundamental architecture that needs to be put in place to enable monetization. So what you see on the right-hand side is kind of a business reality. As operators, as service providers go out and build networks, it takes a lot of investment to put all that infrastructure in the ground. The reality is, though, that for the basic transport service, users are only willing to pay so much. So it's necessary to find creative ways to run applications and services that users will find useful, that they're willing to pay more for. Now, the question is, how do you enable that? And we think that from a network infrastructure standpoint, there are two key elements. One is we need to be able to increase service velocity, service creation velocity. What we mean by that is we need to create an environment in which applications and services can be prototyped and deployed more quickly. And a big element of that is making sure that the platforms themselves are open. And as you'll see shortly, that's one of the fundamental tenets that we are putting into our designs. The second thing that we have observed is that thanks to both technology transitions as well as some of the new innovative applications that have emerged, there's the ability to, let me just play this animation out. There's the ability to, in real time, observe what's happening in the network and react and adjust to it. Now, there's one obvious implication of this as you see this animation play out, which is, for those of you who've been working with networks for a long time, feedback control and the idea that you monitor what's happening in the network and you take corrective action is kind of obvious, right? I mean, that's how we deal with congestion. That's how routing protocols work. So that's a given, that we need to support. But what this architecture is highlighting is the following capability. The infrastructure layer refers to the network elements. Out of the infrastructure layer, with the appropriate real-time measurements, data is being fed up into an analytics engine that sits in the network. That analytics engine in real time is able to process data, make decisions, and feed that to a policy engine. The policy engine is the entity that's aware of, for example, subscriber preferences. What do users want to do? What service have they subscribed to, and so forth. And then based on the policy engine's decisions, the actions get fed back into the network infrastructure. Now, this has very powerful consequences beyond optimization when you start thinking about things like analytics and the ability to, let's just say hypothetically, if the network could track what an individual user was doing with every packet, the possibilities are endless in terms of the kinds of services and applications that the operator could then offer up to the user. So I'll give you a couple of tangible examples of that as we go through the presentation, but we're having some problems with the clicker here. One lesson learned: if you have something with a low battery, avoid animations. Jared, you heard that? Just kidding. So, wanted to segue from the discussion of architecture to some of the experiences that we've had with very large-scale deployments of small cell networks, because we think that there are insights in here that apply not just to to the environments in which I'm presenting them, but more broadly to how small cells need to be deployed. So this chart shows you the traffic distribution at the last Super Bowl. This was in New Orleans, Louisiana. And the first takeaway here is, if you look at, by the way, Alan, we do have a scale here. The first takeaway here is just the sheer magnitude of the traffic. The peak traffic is 400 megabits per second. Now, this is aggregate traffic. This was for the entire stadium. There were 70-something thousand users. Of the 70,000 users, there were more than 10,000 that connected at some point in time to the Wi-Fi access point infrastructure that was inside the stadium. So the number one takeaway is just a huge amount of traffic. I mean, imagine carrying that on a macro RAN with all of the capacity limitations. The second observation is that user behavior is evolving. We are used to thinking of download speeds and download bandwidth requirements being many times that of upload. But as you can see in venue settings, it's exactly flipped. Because of the use of social media, because of the way in which people now upload content, you can actually see that the traffic out of the stadium is almost 2x the traffic coming into the stadium. The third observation is that when you have network events, there can be dramatic shifts in traffic. Now, for those of you who are not American or may not have followed the Super Bowl, something very interesting happened at the last Super Bowl. There was a power outage. There was a power outage for an extended period of time. And what you see is that during the power outage, clearly there's a big blip in the traffic. Now, in this case, it just so happens that it goes down. But the key takeaway here is that in terms of traditional processes of dimensioning and traffic management and so on, they just wouldn't adapt to these type of traffic fluctuations. So it's extremely important to make sure that in terms of the management tools and the control tools that we build in capabilities for SON, for dynamic management of network resources to be able to deal with this type of fluctuation. The next example that I wanted to walk you through was a hospital example, and it's it's symptomatic of what we are seeing more and more in enterprises, in hospitals, in universities, where the IT folks who are deploying the service want to have Wi-Fi, and they also want to have licensed radios. And ideally, they want to have it co-located. So in this example, this is a hospital example, very large hospital chain in California that we work with closely. They have a very large deployment of Wi-Fi access points, and they use it for a variety of applications. Of course, they use it for the usual, doctor looking up medical records and so on. But they also use it for asset tracking, for example, to keep track of medical paraphernalia, pumps and so forth, right? Just to make sure nurses aren't hoarding equipment. But what we've been working on with them is the idea that, from their perspective, one of the mission-critical applications is to be able to page doctors, to be able to send SMSs. And they don't believe that Wi-Fi is the right way to do it because of some of the availability concerns. So they're working with us to integrate technology that we have that is a companion to our Wi-Fi access points that just plugs in, because what that allows them to do is it allows them to go into an existing installation, just upgrade the Wi-Fi infrastructure to add licensed radio capabilities. In this case, this is a UMTS module, and be able to support some of these voice and SMS services. The third example that I wanted to walk you through was a very large LTE deployment that Korea Telecom has done. And in this deployment, they used our gateways, and so we had a first-hand look at the total, at the impact of the build-out. And the key takeaway here was something very similar to what Alan pointed out, which is, number one, we observed that every user had effectively higher data rates after this infrastructure was put in place. Now, that's not surprising because the users are closer to the access points, so you expect the data rates to go up. But the more interesting thing was, as a result of that improved experience, each user made more use of the network. So the aggregate capacity requirements per user went up, and it was quite dramatic. We have the data, we can't share that publicly. So the takeaway there is, as you make the experience for the user better, the user starts to use the network more and more for new applications in some cases, which in turn increases the amount of capacity that's required, not just in the small cell part of the network, but also in the core network, the backhaul, and so forth. Now, all these examples I've talked about so far have been in the realm of the traditional, how do you build out a network, traffic capacity, sizing, congestion management, and so on. But what's happened with a lot of our service provider Wi-Fi deployments in the last year is that, once the transport problems were solved, once the scaling problems were solved, just about everyone wants to figure out, well, how can I use this infrastructure to do more interesting things? How can I build services? How can I build applications on top of this infrastructure? So we've been working on that, and there's a variety of applications and services that we've been developing with our partners. But I wanted to focus on one class of applications because we see a lot of interest there, and we think that this applies equally both to service provider Wi-Fi as well as to licensed radio technology. So with analytics, the idea is that you can process information and do something useful with it. But in this particular case, the key is if you could track individual users, there's a lot of questions that you could answer. For example, with a mall-like scenario, you could keep track of where is the foot traffic, where are people going, are they, do they tend to cluster in certain areas, are there certain areas which are completely barren, and so on and so forth, right? And you can easily see how that would translate into the types of things that a mall operator or a retail store owner might be very interested in and might be willing to pay money for. For example, if you put up new signage, if you put up new advertising, how effective is that in pulling users to a certain location? Or even something as simple as rentals. If it turns out that certain areas of the mall are more easily accessible, and that's obvious from the location data, then that might be used to set pricing. So what we see is, we have certainly developed a lot of the component technologies. We've developed a lot of very interesting applications built around this. And what we're beginning to see is that service providers are also experimenting now with these ideas. I just threw up a few examples of stuff that's publicly available from various service providers, where they're essentially trying to sell information that their users will find useful, that's built around this concept of being able to track location and make inferences based on aggregate location data. Now, segueing from some of the experiences that we've had and things that we've been doing over the past couple of years to the present, when we, Cisco, looked at overall what needed to be done in the space of small cells, our sense was this is our architectural vision. You see all of the various access point stuff on the left. But it was our sense that in order to stitch together an effective end-to-end solution, including the ability to provide applications and services, that there needed to be some heavy lifting. And we've been working on that along with a lot of our partners. We've also made some substantial investments in the course of the last year. We've spent almost $2 billion acquiring some very interesting technology companies. So let me just quickly walk you through some of what we've done. So I'll start out with Intucell. Some of my Intucell colleagues are in this room, and I hope you have a chance to interact with them. Intucell is a small company, was a small company based in Israel, and they had very innovative ways of managing and controlling the network. I mean, I could kind of simplify it by calling SON, but I don't think that captures the entire magnitude of what they do. And they've been able to demonstrate their technology in live networks and demonstrate, not just for small cells, but overall for wireless networks, that the technology can be very effective in reducing operator costs and improving the user quality of experience. The next acquisition that we made was BroadHop, which is a company that was developing policy engines. So think of it as it's a server in the network that has a state about individual users, and based on that can make decisions. Think Smart Technologies, which has the enabling technologies to allow some of the location-based analytic services that I talked about earlier. Carradine, which is used for planning services for the wired network, so think of it as the back end of the network. And finally, Ubiquitous. So I'm delighted to announce that we closed the Ubiquitous acquisition last week. And for some of you who've been coming to the Femto Forum, as it used to be called, for several years, the Ubiquitous team, Will Franks, Pete Keevil, Chris Gilbert, they're some of the technology visionaries in this area, and they had the passion and the belief to invest in this area long before it became mainstream. And we're delighted to welcome them to Cisco. And as we integrate the Ubiquitous technologies and the Intucell technologies into our product portfolio, what it allows us to do is augment our overall product portfolio and also build and accelerate on some of the product initiatives that we've been driving. So specifically, we believe that it's important for the industry to embrace multi-standard radios, which is 3G, LTE, and Wi-Fi. Of course, depending upon individual geographies, some of that technology may not be required. But we are making large investments to make sure that we can drive that integration and to do so in a cost-effective manner. And a big portion of it is also making sure that the companion network control technologies for SON, for policy, for management, are developed in concert with that. Ultimately, our goal is to make sure that whoever deploys small cells doesn't just have the individual piece parts, just the blocks, but has this control capability. We call it an intelligence layer that envelopes all of the network infrastructure and the control points to allow for optimization and monetization capabilities along the lines of what I discussed earlier. So this is a quick look at some of the products that we've been developing. We have what we call the 3000 series, the 5000 series, and the 7000 series. The 3000 series is primarily residential. The 5000 series is targeted for the enterprise, and the 7000 series is targeted for venues, outdoor deployments, for example, stadiums or airports or railway stations. And essentially the key difference between these different class of devices is in the transmit power or the number of users they support. So we are developing all of these in parallel. Now, as we develop small cells, as we take this into large-scale deployments, the single biggest problem that everyone picks up on is backhaul. You saw Gordon's pie chart where I think it was 28.7% of the responders indicated that backhaul was the biggest problem. And we absolutely agree with that. If you look at the set of challenges there, the most obvious one is that small cells get deployed in all kinds of environments. So you can't count on fiber being there. You can't count on a DSL drop being there. So there needs to be a variety of physical layer access technologies that need to be supported. In some cases where the only technology that's available is wireless, there are competing ways of providing that wireless coverage, for example, with non-line of sight or line of sight type techniques. So net-net, what we see, and I think both Alan and Gordon touched on this, is today there isn't one technology that meets all of these requirements. So won't go into the details of this. This must be very familiar to a lot of you. The key takeaway here is that there's a variety of wireless backhaul options, and depending upon the distance that the signal needs to traverse and depending upon the capacity that's required, there's various different technologies that are available today that make sense. So what we have done as a result of this is working with our service provider partners and working with our technology partners, we have determined that the best way to address the different sets of problems is to create what we call an ecosystem. So I'm delighted to announce that we have a wireless backhaul ecosystem that essentially allows any service provider to use technology that's built around our backhaul architecture. We call it UMMT for Universal MPLS Mobile Transport. And that architecture defines several capabilities, including OA and M, timing, network management. And the idea here is that with our partners, with Blink, with Fastback, with Radwin, with DragonWave, NEC, and Ciclu, we are providing a completely interoperable end-to-end solution. From an architecture standpoint, we make sure that we test not just interoperability, but also address some of the problems that are typical in a microwave backhaul deployment. For example, if the microwave link quality changes over time, there are corrective actions that need to be taken in the transport system. So we've developed a lot of network management and algorithmic capabilities to deal with these problems. So we've been working with these partners for a long time, and as we move forward, we will formally announce this ecosystem, and we are happy to share more details with any of you in terms of exactly what this means, what the certification program looks like, what testing has been done, some of the architectural elements, and so forth. So in closing, Instead of walking you through all the architecture components again, I just wanted to leave you with two thoughts. The first is that we think that for small cells to be successful, the industry, all of us together, have to make a substantial investment. And we certainly have stepped up to the plate. We are making those investments, and in all the relevant areas, in the development of access points, in the development of gateways, in the development of network management capabilities, including SON. Equally, we believe that we ourselves are able to address a portion of the problem. We are working with a lot of the folks in this room. I talked about some of the backhaul partnerships earlier. We're also working very closely with semiconductor partners to drive some of the next generation technology transitions that are necessary for this industry to be successful, working with a lot of software partners. So for anyone that believes that there's technology that you have that would be a good addition or a good complement to some of the capabilities that we are developing, we are here. Please come talk to us, and we'd be delighted to have a discussion and follow up. So with that, Gordon, any questions?
Yeah, we've got time for a couple questions. If you'll state your name and affiliation part of the question, that would be great. Any questions? Right here.
Hi, my name is Jim Parker with AT&T. I was really intrigued by your Wi-Fi experience with Verizon Wireless at the last Super Bowl, where your slide had shown where the network traffic really dropped off during the power outage situation. And the reason for saying that is because we have a neutral host distributed antenna system deployed at that venue. We have dedicated power from the utility. We have a dedicated battery backup, and we had a dedicated generator at that venue. And I'm happy to report our system was not affected by the power outage. However, our network traffic on the data system spiked at the time that the power lost. So when I saw the slide, my takeaway was, and my question is, were those Wi-Fi APs backed up?
Right. So I'm going to take the Allen law exclusion on this. So I'm going to say that I'm happy to have a follow-up discussion on this, but maybe you shouldn't comment publicly on this.
I'm glad.
I'm happy to follow up.
I was thinking the same thing, Jim. Any other questions for Partho? All right. Oh, did we use their one right here?
Adrian Pike from Orange. One of the major topics we're discussing within Orange is whether SON will work effectively in a multi-vendor environment. So we obviously have our vendors for our macro layer, and we're thinking we may, in order to have good SON performance, we may have to use the same vendor for small cells. Would you care to comment on that, please?
Absolutely. We have a lot of empirical evidence on this because the Intucell team has been working on multi-vendor SON algorithms for macro RAN for a long time now. And I think the key is as follows. I think the key is to make sure that there's a clearly defined interface and a set of statistics that can be exported out of the access points, the eNode Bs. And likewise, in the other direction, to make sure that there's a clearly defined set of control interfaces, to do things like create neighbor lists or assign hopping codes. As long as that's done, the technologies end up working quite well together. And, we have, again, we should do this in a smaller setting with our Intucell team. We have tons and tons of empirical data that we can walk you through that highlights how, that can be made to work. So it works in the macro RAN network today, and, we are absolutely confident that it'll work with small cells and macro RAN as well.
There's a question right here.
I see Ronnie over there. Ronnie, please expand on that.
Hi, my name is Ronnie Wellingstein with Cisco, previously Intucell. Just to add two remarks here. Jim from AT&T, indeed the performance in AT&T's network during the Super Bowl was superb. In fact, our sound system was deployed in that event, and we used a dynamic load balancing in real time, and we have excellent results that we published together around that. On the question that was raised about the position of the large vendors regarding small cells, I guess that this pressure is coming from the vendors, from the major vendors, as part of their attempts to avoid the situation that the radio access network is about to be commoditized. And it's basically the operator's decision whether they want to push and support this kind of trend right now or to try to stop it. As far as we know, the largest operator have already committed to open the standards to enable that, because this is the only way to basically make a dramatic impact on the cost of the radio access network. So in a way that the next, in the next couple of years, the $40 billion market of radio access network will sure change, and we'll see many more vendors in the small cell space. I think the key to that is through end-to-end multi-vendor topologies. SON is definitely part of it. Thank you.
All right, with that, we're out of time. So, Partho, thank you so much. All right, so the next thing on the agenda is, in fact, a coffee break. So the coffee break will be held together down in the Monarch room in the networking session.